See that? That's the model. Here we go. So these are 10 amp hours, 12 volts. So it's 12.8 volt nominal, and it can go up to about 14 volts, or I think it's 14.8 or 14. You can see the specs of the front here, and so that's the thing right there. And we already have the bus bars on the center tap. So this is where the BMS is connected. So you can charge or discharge from this side. The only thing you can able to get or draw a huge amp hours, but you can able to draw power like 50 amps, something like that from here. You can check out my videos on the other playlist on this Relion batteries, then you will see what I'm talking about here. So here is without the BMS. You can deplete the batteries, but you gotta have your charge or inverter supposed to, or you have to have something that able to cut off the power so you can drain your batteries completely to zero. But here, up here, can help you not to deplete your battery completely, and you can charge them effectively, because that's a BMS, battery management systems, is up here to regulate or to charge the battery, the cells individually, right here at the command center of the JW Solar USA. I set up something here. You can see we have about approximately a 3 or 4 gauge, a 4 hot or 3 hot cable. I don't want to move it too much because I have a disconnect here. There's a fuse, approximately 300 amps here, and tied to this guy here. We're drawing from here, and we're going to be charging from the other side here. So charging from here, we're going to be tapping to this center tap, the positive, and we're going to do on the other side here, so we can able to charge and discharge respectively. So now I end up coming to our lovely charge inverter, here, which is the Magnum Energy, the MMS1012. So I can go back here and show you. There we go, MMS1012. So that means 1,000 watts at 12 volts. This is made in West Virginia. Seattle. From Seattle. See that? These are all the specs for it. And so we gonna sit right on the threshold where we can able to draw or put the batteries into that input specifications. So what we're gonna do right now, testing these batteries today. The time has come, and we have the MERC Magnum remote control, and this is the 50. Oh, this is a MEARC, which goes as a favorite right here, the favorite. So this one is the advanced remote. So we have the AC out and the AC out right here. It comes to this GFCI plug, something like that, and you will see it has a fast charger, the PC, and it has a USB, and which is a 6 amps. This thing can deliver to charge your thing. And this one is mounted in a thick plate that came from equipment, like a band equipment, like an amplifier, heavy duty something. So I can just attach this thing. I can able to throw it on a wall or anywhere. It's already got the holes already here already. I can able to swap this in different mounts anyhow I want it to be, on a rack or something. So you can see it has the AC output of 15 amps. So which is, we use a 10 gauge cable here. I can use something smaller, but I have a 10 AWG American, and it can drive up to about 30 amps. It's an overkill, and the inputs we can charge up about 20 amps here. So I can able to get away with 14 gauge or 12 gauge wire. easily. So I put always my install, you guys remember, I always have my bushings to suspend the machine from the surface itself, so you can have a better ventilation and the heat, because there's a huge transformer here, because it's a kind of low frequency, and it's really cool. Magnums are really cool. That's all I can say. Check my videos on Magnum, MS, and all the PAEs. You can see what I have for Magnums. But it has a huge transformer here they can do, because it's a low frequency, it's pure sine wave inverter. And here, this is where you get your AC input to charge your batteries if you want to. I haven't hooked up the wire here yet, so I just created something here. I haven't got it into the box, but we want to test these batteries, put them on load, and see how they go. So here I have added a disconnect, which is here. Can go up to about 300 amps. So here we go. I'm gonna turn the ignition right there. There's a fuse right there. Anything that happens, it arcs. So there's a little light here that's gonna illuminate. It's gonna flash, but due to flash on the camera or the light on the camera, you might not see it. But I'm gonna initiate that. See, there's a little blink, and there we go. Doing a self-test. Then it's gonna ask us to program the see, that's the version, the inverter and the remote, and to the time. So by doing so, we just bypass that, and the inverter is off. So now we can just press the power. Now it's inverting. Okay, it's on. You see it's pulsing right there. That means it's sending power. Now the inverter is giving power out to AC output. So let's grab the tester, and we can put and see how everything comes out. It's a pure sine wave to 120 volts or 119. Stay tuned. And the batteries are sitting 13.8. These batteries has been sitting for a long time without charge, and they're all parallel right now. So on the BMS, so it's supposed to give us a better balance. So now what we're gonna do, we're gonna stick these probes right here. We have the probes already inserted to the AC output outlet here. We gotta set it, sorry, we gotta put it to here. I hope I didn't. Now it's giving you a dash because we have it in a search mode. So we're gonna take this inverter from a search mode because I had it on the 50 watts. So any load you can see, you have to see a 50 watt load before it's gonna give power out. So it's searching. So this inverter, I think just on idling mode, I think is a 7 watt. It takes from a 3 watt approximately. See, it takes. So now we're gonna dial this guy down by pushing the rotary on this thing. See the arrow already indicated. So we're gonna drop it all the way to 0 or off. Then the inverter gonna just give out the power. Check this out. So I'm gonna push down the select. So I push down this thing and the power indicator here. Better contact. Then we turn this one to the AC. Look at that, 120.9 volt. And now we have this thing off, the search, and we are inverting. That means we are making power. So stay tuned. Let's do a test. So we have this guy right here. So we're gonna test it to here. And what we're gonna do and take this plug, 120 volts US, and connect it, insert it, and now it's in there. So now we have the invert. So we drop was 13.8. Now the inverter is on. So it takes about 2 millivolts, 13.6, and now we're gonna turn this guy on, and there we go. See that? Spinning. And look at this. I'm gonna increase the speed to mid and high. Here. going high. Look at that. Hundred of a volt. It was 13.6 and 13.5. We have this, so we can able to charge our phone on this thing with a fast charging as well, because it has the PC, which is the smaller side, which is here, and we have, I think that's what it's called. See, it's a 6 amps. It's a fast charger, and here with regular USB 3.0. So the batteries are doing well. We can able to plug a freezer or refrigerator or computer or anything. Then there you go. Look at that, 13.4. Remember, these batteries were not charged. I just put them together. It was really hard to charge because I don't want to charge them individually. I want these batteries to be parallel, and so that they can balance properly and discharge them. That's what we're doing right now. So now it's working.